it will be posted on AInspire's YouTube channel later on, and so you can check that out whenever you'd like. And like I said before, we'll begin in a couple minutes, just waiting for a couple more people to join. And I also should mention that the meeting has a time limit of around like 40 minutes. So once those 40 minutes are up, I will put the link, the invite link, back into the chat, and I believe we should be able to just join the meeting again, because I think the 40 minutes only lasts for a certain number of, like, the session itself. So that should, but yeah, that'll be once the 40 minutes are up, and I'll let you all know when that happens. Yeah, so just about one more minute and we'll get started. All right, let's go ahead and get started. And okay, I can move the chat over here, so I'll do that. Wait, can you all see the chat on the screen? Because if you can't, I'll just move it. Maybe I can move it down. Oh, you can't see the chat. All right, that's good then. All right, so let's get started. So hello, everyone. Welcome. This is AInspire's Research Paper Breakdown Workshop, and I'm glad you are here. All right. Oh, there we go. Okay. So hello, my name is Erin. I'm based in LA, and that is where I am a regional leader leading this workshop from. And some fun facts about me are I'm passionate about neuroscience. I think it's a really important field within science just because, you know, it's the essence of us, of humans. And so I think it's just so utterly important. And there's always something more to discover with it too. And so I do love neuroscience. Second fact is I'm in band and orchestra playing the oboe. I've been playing since about 6th grade, and I love that as well. And then the third thing that I'm really into is artichoke hearts. I was introduced to them in a cooking class back in 4th grade, and I can't cook for my life now, but I was at least introduced to artichoke hearts, and I put them on everything, even pizza. I mean, I put them on ice cream if I could, if that wouldn't taste bad. And then my email is erin.n.vincent@icloud.com, and feel free to reach out. I check it often. So if you have any questions, comments, or concerns, just feel free to reach out. So some of the workshop objectives and the breakdown of what we'll be doing is to understand the information presented in a scientific research paper and to find the important parts of a research paper. And so the way I'll be doing that is I found a research paper that I think will be helpful and a good model for us today. And we'll go through that, and I'll go through the different sections and highlight some of the main points and why the sections are important within the paper itself. And then also to find reputable works on different databases where you can get started with your own independent research. And so the overall goal of the workshop, so at AInspire, we really want to equip people to be comfortable with entering the world of artificial intelligence. And to do this, we teach them technical skills, theoretical knowledge, how to approach and build relationships with college professors, and how to understand scientific literature. And this workshop specifically aims to fulfill the last goal, which is to understand scientific literature. And so hopefully, by the end of this workshop, we hope you won't feel too daunted by looking at complicated research papers because you'll know exactly how to tackle them efficiently. And like I said a little bit earlier, I would like to mention that the workshop is being recorded and it'll be posted on AInspire's YouTube channel, which I believe is called AInspire Team. And so you can go back and view it anytime you'd like to. So starting off with some tips. So make sure you can understand every word in the title of the paper, and often it can reveal a lot, even though it's a few words. And you don't have to understand every single word mentioned in the paper because it can be complicated. And Google is always a helpful resource in looking up some of the words, but overall just understand enough so that you can have a meaningful conversation about the information presented. And so some of the ways you can really dive into a research paper is through a method called the 3-pass approach. And so it's a 3-step process that can be really helpful in helping you understand the research paper. And so diving right in, the first pass is really just helping you get a feel for the paper, and it's a very much a bird's eye view of it. And so in some of the things in the first pass, you'll read the title and abstract, and which I'll cover a little bit later, and then read the subsection headings and basically ignore everything else, and understanding those aspects will come in the next 2 passes, and then glance at the mathematical content, if any. And then there's also something called the 5 C's, and these are category, context, correctness, contributions, and clarity. And so these are essentially different categories that you should be able to answer. They come with questions that you should be able to answer by the end of the first pass. And so I'll go through each of them and kind of explore some of the questions you might ask with each one. So as for a category, it's essentially asking what the main purpose of the paper is. So for example, is it an analysis of an existing system? Is it a description of a research prototype? And more. And as for context, this begs the question of what other papers the paper is related to, maybe some of the sources that it lists at the end, and just how it relates to different experiments that have been done before, and also how the problem proposed in the experiment was analyzed. And then moving on to correctness, are there any assumptions in the paper and do they seem valid? So kind of what makes the paper credible. And then as for contributions, you might ask, what does this paper add to scientific research? And then the last one, clarity, it's basically asking if the paper is well written and clear in its main points. So those are just 5 categories with questions that you may ask that, like I said, you should be able to answer by the first pass, but it's really just a bird's eye view of the paper. And so diving a little bit more in depth to the paper would be for the second pass. And so in this, you read everything but the proofs, because that'll be more so in the third pass. And then also to jot down key points in the margins and look carefully at all the graphics. And you don't have to understand them completely, but just get the gist, because the really in-depth material will come in the third pass. And then mark relevant references for future reading. And so this is really just grasping the content of the paper and then really diving in if you're super interested in the paper and it relates directly to research, your independent research, if you're doing any, would be the third pass. And so in this step, you might want to challenge every statement that is made in the paper, mentally reconstruct the paper, and rephrase the technical aspects to make them easy to understand so that maybe even someone like a 5-year-old can understand the paper and what it's covering. And so this is truly a deep dive into it, a full in-depth understanding. And so pay attention to details. And by challenging every statement, reconstruction, and rephrasing the technical aspects, that's really showing that you have that full understanding and you can start to form your own opinions based off of what you read. So that is the 3-pass approach. I personally think it's a really good and efficient way to kind of dive into a research paper rather than just skimming through it once, because if you do that, I don't feel like you'll understand it fully. And so I think this is a really, really good method for truly understanding a research paper. All right, so for time's sake, I can't go through actually, like I can't put the 3-pass approach into action just for time, but I will go through each section and kind of explain why they're important and why they're there in the paper and what they contribute to it overall. Okay, so this is a paper from the Worcester Polytechnic Institute, and so diving right in, we first have the title, so which is C. elegans transcription cofactors, and we can actually tell a lot from the title already. And so looking at the first two kind of words, the C. elegans is, if like from a little Google search, you can pull that it's a nematode transparent worm. It has about 302 neurons, and so, and off of other factors with it too, it makes for a really good study subject for us in different experiments. And then based off of the next two words, transcription cofactors, we can kind of tell that the researchers will be focusing on these elements, and we can pretty much assume that it's going to be in terms of the worm and how that'll relate to their overall function. And so moving on, they have a little bit of an introduction. They have a table of contents. Not all research papers have a table of contents. Most do, because I think the shorter ones don't often need a table of contents just because of their length, but the longer ones, such as this one, do. And then this one, not including the appendix and references and things, the paper itself is 39 pages. But most student research papers that you would do would be anywhere from 3 to 20 pages, with 3 being obviously the smaller projects, and then 20 being the pretty extensive and data-filled ones. And I should also mention that the research papers that have a lot of data and mathematics like packed into them will normally be the longer papers. Okay, so the abstract, this is so important. So the abstract is basically an overview of the experiment. It's a summary. It's really concise. As you can see, it's just a small paragraph for this one. And so essentially in this paper specifically, what they do is they define essential vocab words. And if you don't know some of them, like maybe you don't know what this technology is, then you can always use Google and look it up. And so I found that the PSI MI 2.5 parser is a tool used by scientists to record protein interactions, which will come very much in handy in the experiment. So yeah, so the abstract is basically just an overview of the paper itself and what it really covers, and basically the guts, if you will. And this paper has acknowledgement. Not all of them do, but can you mute yourself, please? I believe it was Skylar. Thank you. Okay, so moving on to the introduction. So it really introduces the experiment, and it describes the main ideas in a lot more detail. As you can see, this is a lot longer than the abstract. It's nearly 2 pages long. And so in this paper, it defines more of the terms. As you can see, like the GTFs, general transcription factors, it defines that a little bit, the transcription factors in general, and then the transcription cofactors. So different vocab like that they define, and defining these is really important for the experiment itself, because that's what they're focusing on, is finding these in the worms. And it also gives a background on the experiment, And so it adds to what's already known. And so becoming familiar with these factors in the nematodes or the worms will aid in human studies, and we could possibly relate what we find in this experiment with the worms and relate it to humans, which is pretty important. And then it also wrapped it up in this last paragraph down here in what the experiment would actually be covering, and it's essentially identifying potential transcription cofactors via background research and collected in the worm's genome through a technology called BLAST, and it evaluated what they found using an interactome data parser with the worm's phenome. So that is an introduction of the introduction. And then moving on to the background, not all research papers have a background, and some of them it's not necessary, but in most it is. And so it really, in this one, it goes more in depth on the vocab terms. As you can see, it goes more in depth on things like the transcription, on how transcription relates to DNA, and it gives a figure on that as well, and GTFs, and then it goes on with that and really goes in depth on what these are and how they relate to the experiment. And then it is also, it's helpful in skimming this this is formatted really nicely because it just lays out the vocab terms for you, and you can go to which one you're interested in reading or all of them. And so the 3-step method would really help here in going through each of the vocab words and trying to tie them into the actual experiment. And then there is also often a hypothesis. We've learned that, hypotheses are really important in science. And in this case, actually, there really is no hypothesis, because in this paper, the researchers are discovering something versus actually testing something, and a hypothesis, itself is a testable question that is being proven or disproven in the experiment. But there's really nothing to be proven or disproven in this one because it's based on discovery. So you can see all the vocab words being defined here, the TFs, and then you have the TCFs, and they also go a little bit more in depth with the different figures and models. Transcription regulators. And you don't have to read through all of it. I mean, a lot of this is way more complicated than what we would learn, say, in high school. College students would really be diving into this a bit more because they have a lot more background on what these things mean. We go down here on the next genome, like databases, interactome. The interactome is actually really important in this experiment. We'll get to that a bit later. Okay, so the next section is normally called methods, and sometimes it's called also materials and methods. And what this section is it's really how scientists gather data. And in this paper, it's put in a more decipherable form, and it lays out the materials used, like the different technology that it uses to push toward its goal. And so in this experiment, they would use interactomes, phenomes, and technology called SMART. They also use BLAST, as you can see here, and also here. And it tells you a little bit about why they were used and how they contributed to the experiment. And in this one, BLAST specifically is one of the most important tools that they use. And they said it's used to identify those proteins with the desired domain within the worm's genome. So that's super important because the worms there are the subject. So that's super important. And then they go on to list interactome databases. That's super important because the interactome is really what they use to evaluate the results. So we have that. And this is a little bit what we talked about earlier that they introduced in the abstract. And these overall vocab terms, you can also, if this is a little bit hard to understand just because it's written by professionals and they have, like I said, a lot of background, on what these things mean, and they've probably used them before as well. So if you need to Google them, Google's a great resource to help you understand it a little bit more and give you a little bit more background on what the researchers are doing. Okay, and then the results is obviously very, very important. It's like the final wrap up, it's the observations, and it summarizes the findings that the researchers had. And so in this paper, it's an overview of how the data was gathered, and the following sections are in-depth explanations of each method of collection. Excuse me. And so how they basically collected their data on the worms and their different their transcription cofactors. And so they have some figures here. Those are the interactomes. As you scroll down, they have their different, so the different technologies that we were talking about earlier, this is what they found from using those. So for example, BLAST, what they found from using that technology and how that contributed to the experiment. And you'll also find graphs. This is an example of a data set that you might find in a research paper. And they explain that a bit, not only with the caption, but usually in the next paragraphs, as you can see here. A little bit more data, a little bit more data. All right. Yeah, so they really go in depth on what they found, and sometimes it can be pretty complicated. And in this experiment specifically, this looks super complicated, but they explain it up here. It's the 98 interactions that were found with the interactive databases and on the transcription cofactors and transcription factor functionalities. So you can see here. And so that's basically a chart of that. And for this experiment, they actually developed computer software to do this quickly. So this was developed by a computer, which is pretty cool. And it really shows how important AI has become to scientific research. And then this is the second to last section, and it's called discussion, and it can also be called a conclusion or both. And so this essentially wraps up the overall paper, and it summarizes all the data proposed that we just scrolled through. And so it just provides a nice summary of that. And then, oh, it looks like, oh no. Oh, sweet. Okay, the notification for the 40-minute time limit just popped up, but it looks like they're removing it. So that's awesome. So it looks like we'll be able to keep going. Let me open the chat real quick. Okay, we're good. All right. So yeah, it looks like we'll be able to keep going. Sweet. So yeah, so with the discussion, it wraps up the data, which was a lot. So this is pretty useful. And it can also explain the results without the data, without the actual numbers. It also explains, just so it's easy for peers to understand, because the actual numbers are explained in the data section, the results section. And then it also explains some errors or mishaps and sources of error that the researchers found. And they can also compare it to other papers and some of the references that they list in the next section that we'll cover. And so, for example, like some found this factor while others found this, and then this paper can contribute to that and really just progress scientific research. So it really all comes together. It's really awesome. And then, so in this paper specifically, it's an overview of the results. And so they say here, a list of 162 of the worm's proteins were predicted as TCFs, and this was really the goal of the experiment, was to discover, using different technologies like BLAST, to find these protein interactions and these transcription cofactors and transcription factors within the worms. So that is, yeah, so they basically go over the goal of the experiment and really just a wrap up. And they also discuss, like I just said, difficulties And later on, they explain a little bit how they found difficulty identifying histone modification and just different things like that. And in this experiment specifically, they had these issues because of the lack of previous research. And so it really just highlights how much there is left to discover. So it's really great. And so this section is just a way for other peers to look at it and see what they discovered and try to compare it to their own work in order to contribute to the field or the topic in general and really progress it. And then scrolling down to the next section. Oh yeah, actually I want to mention this, the interactum evaluation. And they mention the interactum a lot in this, and it's one of the main methods used. They covered it a lot in the methods and materials section, and really just everywhere. It was a really vital tool that they used in order to discover what the transcription cofactors and factors were, and transcription factors were for the worms in this experiment. And the very last section, there is a section after this, but it's really just an appendix and it has just a lot more data. So there's that, but the main last section is called references, and they have a lot here, and this was a long paper though. And so it's references, and they basically list out where they led. It cites the trail that led them to their conclusion and what they referenced throughout the experiment to lead them to their conclusion and their results. And I also want to touch on the citation method. And so normally a paper, unless specified otherwise, is sourced in MLA formatting, which is commonly used in a lot of English essays, and so in a lot of school assignments, even in high school and sometimes middle school too. So we often use MLA. Are a lot of you familiar with MLA? Just write it in chat. Yes, yes, yeah. MLA is pretty useful and used pretty widely, mostly in high school and then also in college as well, and just throughout schooling career. Yes, okay, yeah, pretty much all yeses. Nice, yeah. So MLA will prove to be very, very useful. If it already, it's probably useful to you now. Yeah, MLA is very useful. I can't stress that enough. But APA is another citation method, and it's often used in psychology specifically, but some journals do use it, but it's specified if it is used. So my point is that MLA is the most widely used. So here you can see all of their references, their sources that led to their conclusion. They have a lot of them, so they really dive deep into this topic. Yeah, and then after that is a bit more data. It's the appendix, and not all papers have this, but some do if there is enough data to be presented. So that is an overview of the sections generally found in a research paper. Some research papers, they do vary in length, especially once you get further along into the field. Some, like I said earlier, can be as short as 2 or 3 pages. And then some can be a lot longer, such as this one. Yeah, so just a quick overview. We had the title, which we dissected a little bit. It gave us a general overview of what the researchers covered in the experiment, which is found right up here. And then we had the table of contents. That's pretty self-explanatory. Some have it, some don't. The abstract, super important. And then this one had acknowledgements. And then the introduction is just basically a bit more in-depth version of the abstract. The background covering a lot of vocab terms. And then They had a lot of vocab in there. And then materials and methods, basically the technology section. And then the results, which is obviously very, very important, explaining what they found. And this experiment specifically had a lot of data because they were trying to discover all these different protein-to-protein connections and the different transcription factors and transcription cofactors within these nematodes. And then the discussion to show your peers what you learned and to try to build off of each other in order to progress the topic itself. So that section is super important, super helpful. And then references, which is very necessary, often in MLA, sometimes in APA, but most of the time it is in MLA. So that is a basic overview. And hopefully that was helpful to everyone. And moving on, some resources and databases. I had a few questions about what databases are helpful in conducting independent research. Oh, and I also want to touch on, this 3-step approach. I didn't use it in that last research paper. I did a little bit, but not truly in depth, just for time's sake. But it is very important and super, super helpful to use. So I would definitely recommend it when you're doing your own research paper, and just to kind of structure it in a way that others can do that to your research paper. And then also when you're reading research papers, I would definitely recommend dissecting it using the 3-step approach. And so some of these databases include Scopus, Nature, PLOS1, PubMed. PubMed is pretty famous. A lot of people use it. It has so many resources. It's really great. And Scopus actually, it is also pretty reputable. It has 71 million items covering so many different disciplines. It's very, very helpful. And I would recommend checking that out for sure. And then PubMed has about 30 million items to be used, so that's really great. And then, so these and any database similar to these will be helpful, but I would recommend really knowing the main goal of your research, and that'll help you find the right items that'll be the most helpful to you to read. So instead of just going through papers that like what we just went through, and wasting time and energy on things that won't be helpful to you, it is very helpful to know your research and know keywords in order to look up the right ones. And so hopefully that's a good start for you. And some of these, you can just type these into a search bar and they'll come up, and you can go from there. It's actually really fun to do a deep dive and go down rabbit holes of these. And it's also great for independent research. So overall, definitely know your research before you start expanding your project, and know really the guts of it, if you will. So some advice for that: find a credible database, find a reputable research paper, and then, like we just did, dissect it using the 3-step approach, and really try to implement that. It's super helpful. Okay, let's see. So the next section is for questions. So I hope that presentation was helpful for you all. I hope you're ready to go on your journey to conduct your independent research and form the best research papers that you can. So what are some questions that you have? I see something in chat. So what are the benefits of independent research? So it looks like there are more questions after that, so I'll start with that one. So the benefits of independent research, it's really a discovery for yourself. Some people do it for fun, and some people do it based off of curiosity. Some people do it in an internship that they have. Like if they're working for a lab for a professor, then they will conduct their research for that. And truly at this, I think most people that registered for this workshop are in high school. I think most of us are actually in 10th and 11th grade. So that's great. And that's awesome that you all are getting a head start. And so at our level, independent research can be super helpful to gain experience and to start writing these research papers. Because if you're going into the science field, knowing how to break down a research paper and to write one especially is such an important skill. And so gaining experience, gaining experience, I think, is the main benefit, because it's so important to know how to break down and write a research paper, and then also just to do the research itself. And then what if your research doesn't get published? I'm very interested in psychology, neuroscience. Hey, that's awesome. And have a research topic in mind, but I'm scared it won't get published and I'll waste my time. For that, I would say don't be scared that you won't get published. It really, from failure comes growth. And that's kind of my mantra. And I think even if you don't get published, it's still a lesson and you still learn so much. And also try different resources too. I mean, just because one journal doesn't publish you, another might. So it's really about reaching out and really persevering through those different resources. Oh, here's the question slide. Perfect. Yeah, so definitely it won't be a waste of time. It definitely won't. Doing independent research will be experience gained, which I think honestly is the most beneficial of all, even if you don't get published. Yeah, no problem. Does anyone else have any other questions? Just don't be afraid. Just feel free to put them in chat. And also, if you think of any questions later or don't want to ask them right now, like I said earlier, my email is always open. And like I said before, it is erin.n.vinson@icloud.com. And that is always open, and I check it often. So definitely feel free to reach out. But if no one else has any other questions, then this is the last slide. Thank you all for coming. And please stay in touch. The email for AInspire is contact.ainspire@gmail.com. And their email is also very much open. Their Instagram is @ainspire.team. Their YouTube is AInspire Team, where this recording will be posted soon. And then I also ask that you please fill out the research or the feedback form, which I will link that in chat. Let's see, message here to everyone. There. So that would be very helpful if you could just take the few minutes to fill that out. That would be awesome. And then AInspire has a lot more workshops coming up for you all at www.ainspire.org. We would really appreciate if you would go, and you'll learn a lot. It's definitely worth it. So thank you all for coming. I really appreciate it. I really hope you all learned a lot, and I hope you can go off and write your research papers, do your independent research. It's such a good experience and helps you a lot in the long run. So thank you all. Yay, I'm glad you learned a lot. All right, have a great rest of your days. Thank you.